My name is Gary Alleman. I work for a company called Master Data Management, and we're really enterprise information management specialists, not cloud specialists. So I got asked to talk about cloud architecture for big data analytics, and I thought to myself, does anybody really care? And then I looked at the time slot that I got given, and I thought, does Alison really think anybody really cares? But I see you're all still here, so thank you for being here. I'm going to talk a little bit about architecture, but not too much. In fact, Willie probably covered more about architecture than I'm going to cover in terms of architecture. But I'm going to talk a little bit about architecture, a little bit about cloud, a little bit about big data. So let's start with this slide. It's not original to me, unfortunately. I stole it from one of my partners. But it's a picture that's been floating around and growing over the last few years. Has anybody actually seen this particular image before? It's been out for about 5 years, and it's just getting bigger and bigger and bigger and bigger. Okay. When big data started, we were talking largely about this little block up here, which is Hadoop. There were 3 major flavors of Hadoop. There's now about 10. And most of this other stuff didn't exist. So this is the environment that we're talking about when we're talking about big data. And it's just getting bigger and bigger and more complex. And that's one of the challenges that people like Billy have when they're being asked, well, how do you do this stuff? Is, well, what do you actually mean when you're talking about big data? So what I want to ask people in the audience is, who guys think you're here? Topic is big data. Are you guys thinking about big data? Doing big data, anyone? And what does it mean? Does anybody here know what big data is? Okay, so I'm going to define it. I'm going to define it in 2 different ways. So big data was originally defined by Gartner about 10 years ago. I might be wrong, but it's about there. And they were talking about data that is of very high volume, that is of high variety, so it's different types of data, and data that was rapidly changing. So they were talking about what they called the 3 Vs, volume, variety, and velocity. There's been a few additions to that over the course of time, all right? But that definition is still widely the definition that is used when we're talking about big data. The challenge that I have with that definition, for me, is it's a very technical definition. And it tends to get lumped because of the name. People tend to think it's big data. That's actually not where the problem space is. It's really around complexity. So I prefer to use my own definition, and I've got 2 kind of related definitions that I use. The first one for me is that big data is about rapid time to insight. It's about being able to answer analytical questions quickly from a variety of data sources without going through the traditional data model, the traditional database design of having to build a data warehouse with a whole bunch of complexity and an 18-month development cycle. So it's about rapid time to insight. That's my definition that I prefer to use when I'm thinking about big data. I'm going to put it into context a little bit further on in one of my other slides as well. Okay. So there's a technical definition. Big data has got something in similarity to this concept of global warming. We have people like Mr. Trump in America that don't believe that global warming exists and is a problem. And part of the challenge is because they're having really cold winters. So the name kind of misinterprets or misimplies what's actually the problem, which is climate change. The climate change is happening because the average temperature of the atmosphere and the oceans is going up. But it might, and the same thing with big data. It's actually a horrible name because it's not really realistically explaining what the problem is. Okay, so that's the first step. I'm going to move on. All right. So some of these topics have been covered at length, and I'm not going to go into them at the same degree of length because it's late in the day, and they've been covered. But these, realistically, I've been doing this now. I've been talking to people in the market for 4 or 5 years, and particularly 4 or 5 years ago, but still today, these are the 3 issues that primarily get raised as inhibitors to cloud. Privacy, so that's security and its relations. You guys have had lots of conversations around this. I'm not going to hammer on it. Okay. But when we're thinking about a cloud architecture for big data in this instance, that's one of the factors that we need to address. We need to address the privacy concern, the regulatory concern, the compliance concern, and Billy touched on this at length. Bandwidth concerns. It's big data, therefore. We don't live in America where bandwidth is, I'm going to use the word free. It probably isn't free, but it's cheap and here bandwidth is expensive. Okay, and it's not reliable. So it's great to say I'm going to put a terabyte of data into the cloud, but how do I ensure that I can actually move that data? How do I keep it in sync? How do I update it? How do I manage it? So that's a concern that one has to be thinking about from a bandwidth perspective. And then the third factor is cost. So is it going to be more expensive to put this data into the cloud and store it in somebody else's infrastructure than it is in mine? And Billy's touched on that one, and he's got far more expertise around it than I have. But for me, there's actually two almost ends of the spectrum. And one of them is the misnomer about the concept of big. So a lot of big data implementations over the last 4 or 5 years that have been successfully deployed, there was a shift away from big deployments to effectively tactical solutions. The marketing department wants to get better insights about what their customers are doing by looking at a variety of different data sources. Not actually very big, but complex, multiple varieties of data sources. We want to look at the web logs. We want to look at our security logs. We want to link that to our customer data. We want to link it to this. We want to link it to that, so we can start to do analytics on threats that are coming in from outside. It's a niche application to the security team. It's not for the entire business. So we throw our Hadoop cluster up in the cloud. We put some analytics on top of it, and it's quick, it's easy, it's small, and it's cost effective. At the other extreme, we go to big, where we get economies of scale. It's somewhere in the middle where maybe this cost question comes into play. Would you agree? Okay. So what are the benefits, though, that outweigh those concerns? Some of these, again, have been talked about at length. But the primary benefit, and that's example of those point solutions, those tactical, analytical problems that you want to solve quickly, is business agility. I want to be able to ask a question. I can't afford to wait for my IT department to figure out how Hadoop works, to get the skills, to get the approval, to put the infrastructure in, etc., etc., etc. I can go to cloud, and it's that shadow IT stuff sometimes that Billy's been talking about. It might not be shadow IT. It might be actually sanctioned by the IT department. It might be called a proof of concept, etc. I've got business agility. I can move and I can deliver new capabilities more quickly because I'm not as dependent on just the complexities of making my big organization work. Okay? Prescriptive workloads, I still have to remember what the hell that means, but I do actually know. So prescriptive workloads means I want to only use this when I need it. So there's a couple of different examples of that. The first one is when I'm doing development, when I'm trying to build my data analysis, I don't need huge volumes of infrastructure. If I invest and I build that internally, I'm kind of forced to put all the infrastructure in place very early in my process because I have to plan for when I want to deploy. I was sitting now probably 4 years ago speaking at a conference in Dubai, and one of the speakers there was the CIO of the London Stock Exchange. And he was saying he's not putting his data into the cloud. Not because it's not secure, but because if something goes wrong, he's going to get fired and he doesn't know what they're doing. So he wanted to have the control over the data storage, but what he was wanting to be able to do is say, when I want to run my workload, when I actually want to do that processing, I'm going to do my processing in the cloud. I'll move the data, process it in the cloud environment, and then I will move it back into my own in-house storage. So we're thinking of data often, or the cloud, as a storage capability, but it's not a storage capability. It's a resource capability. It's, do I need processing power? Do I need storage? Do I need applications? What are the different combinations of tools that I need? And how do I scale those up to go from proof of concept to my month-end run when I want to run my big analytics jobs, and then bring it back out of the cloud again and leave it for the next month, whatever it is I'm going to do. Okay, elastic scalability, it's kind of related to the same thing of saying, how do I scale my infrastructure to meet my needs at different points in time in my process? Okay, both in terms of processing capability and in terms of storage. And then it comes down to cost. So I'm now not dependent of making an investment for the long term. I can make my investments kind of month by month. It's not quite as simple as that, but I can optimize my ROI based on where I am in my process, where I am in my development life cycle. I can start with those tactical solutions where the marketing department and the security team are the two people using big data to do whatever it is that they're doing with it, and then I can start to bring that together into my enterprise capabilities and deliver that. Okay? So this is really my slide. The others I'm stealing from various sources. All right. So back to first principles. When we think about data, and I'm a data geek. Okay, dataholic is the word I was thinking earlier. So I'm Gary and I'm a dataholic. I believe that data is fundamental to business. You know, we get with the term data-driven. Has anybody heard that? It gets used for analytics, data-driven analytics. But I'd like to challenge anybody in any business, I don't care what size you are, to switch off the data in your business and then see what happens. We're all data-driven all the time. So what tends to happen when we talk about data to the average business executive or business person, if we're really lucky, they'll be thinking about this. Business intelligence. We want to get some reports out. That typically is what most people think about when they talk to IT people about data. Does that sound reasonable? Okay. So what often happens is they say, we want to report. So I'm going to get to big data in a minute or two. We want to report. We want to do BI. So we go and buy a tool. I'm not going to name any vendors. It doesn't matter. We go and buy a tool and we get the report that we think we want, with or without much business involvement and engagement in defining the process. But what they're actually missing is there's a whole host of activity that you have to deliver as the BI team in order to deliver that report. All right? And I'm going to touch on these. I'm not going to go into them in a great deal of detail because I don't want to bore you all. And what I want to say before I cover this slide in more detail is what often happens is we get the budget to do this. We don't get the budget or the focus to deliver the rest of the stuff. We have to do it anyway. Sorry, yeah? Exactly. Or you didn't know you had to do it because it wasn't explained to you. So what happens is you end up doing all of this stuff, but you do it in a very ad hoc, badly planned, badly documented, non-repeatable way. All right. So let me touch very quickly on how I use this slide and this is my framework that we've been using successfully. I said to you, if you're an IT person, you're the CIO, you're the Chief Information Security Officer, whatever your role might be, you tend to govern this entire enterprise information management environment through this capability within your business, data architecture. So the data architecture of the guys that says, what systems do we have talking to each other in order to move data, to deliver data, to manage data? So very simplistically, that's what data architecture is about. Okay, and this is probably a 5 or 6 day presentation in its own right. I'm not going to cover it in any kind of detail. Part of what you deliver with data architecture is you say, what does my data look like? You guys are all technical, I'm assuming, because this is the technical stream. This is your ER diagrams, right? My entity relationship diagrams. Where is my data? What does it look like? What is metadata? It's my least favorite word in the entire planet, because the definition is data about data, which means absolutely at any time you're talking about the description of something, an attribute name, the length of a column. It doesn't matter what it is, it's metadata. So when we're having an argument now about whether we're doing metadata or not, you could be right and I could be wrong, and we both think we're talking about the same thing and we're talking about something completely different. But metadata is how do we document what our data looks like? And the banks in particular at the moment are being driven by compliance to start to understand what this environment looks like. But it's a massive challenge for us. How do we maintain when we've got 1,600 systems, we've got customer data sitting in 1,000 systems, when we want to do analysis and ask the question of how much profit are we making, what's our churn in a telco environment, we don't know the definition of a customer, we don't know what the definition of a churn is, we get 5 different reports. That's why this is important, all right? We then get into data security. And I'm just going to use it at a very simple level. Who should have access to this data in this report and who should not have access to this data in this report? Data integration, how do we get all the data into the same place? And there's an element of dependency from this. But this is largely driven, my judgment, by the CIO. It should be owned by him and his team. All right? We might build a data warehouse. We might not, depending on the complexity of our data. Okay? Everybody's looking bored, so am I speaking sense or am I okay? Cool. I might have a data warehouse. Cool. And what's the data warehouse doing? It's giving me the ability to run highly structured queries to answer very specific sets of questions against highly optimized data sets. That can do really big stuff really quickly, but it doesn't give me flexibility. Because once I've built that scheme and I've built those structures, I'm kind of stuck with that set of questions that I thought I knew I wanted to answer, and it took me 18 months to get there. But it's necessary. So now what I'm coming to is, if you're a business person, I believe that this is where you should get the same window into this environment. What is data governance? It's this horrible word, All right? But data governance for me is that it's the vehicle by which business prioritizes and links the data management world into their business priorities. It's not about control, it's about prioritization. One of the mistakes we often make, there's a classic example that gets used for metadata management that says, how do we get to the single definition of the customer? Well, there is no single definition of a customer in most organizations. But how do we recognize from a business perspective that we need to have 4 different decisions? We get asked often at conferences like this by the BI people, we want to move data into the cloud as an example, and the lawyers are telling us, no, can we do it? Well, actually, it's neither the lawyer's decision nor the BI people's decision to make. It's the CEO's decision driven down through his channels, and it should be driven here through policies, which in turn influence all of these other things. Data governance gives me data quality that says the content of my data is kind of good enough. That's what it means, really, at simplistic level, all right? And if I have quality data and I have governance, then you can start to deliver master data management. If you try to deliver master data management without these 2 things, all you're doing is integrating data, bad quality data typically. Okay? Bad in, bad out. So I've got big data up here as a block, but it actually isn't just one block. Big data is a combination of all of these things. It's just applying it to this unstructured, highly moving, complex data and allowing me to do it quickly, typically through the use of platforms like Hadoop. All right? So I could have taken out my data warehouse and said, we'll use Hadoop, and we'll do our analytics in an unstructured environment, in a data lake type environment. Should Hadoop always replace your data warehouse? No, they do different jobs. They do different jobs. Can Hadoop replace your data warehouse? Well, there are companies, Sears is an example in the US, that have said we're going to switch off the data warehouse and we're going to replace it with Hadoop. Pros and cons. It's not indexed. It's not going to give you the high performance for those queries. It doesn't give you drill downs. There's a whole bunch of, I'm not going to go into all the details of it. They're doing different jobs. But it replaces some of your data integration layers. It's got its own data security processes, etc. So your architecture, when you're thinking about your architecture, needs to be encompassing thinking about all of these capabilities. You just apply it in this environment to a cloud environment, or you're applying it to a Hadoop environment. Okay? And as Willie touched on, your cloud may not be external. It might be private cloud, public cloud, a combination of the 2. How many of you have got data sitting outside of your organization already? At Telkom, or at IS, or at... that you know about. All right? And secondly, when we start talking big data, we start talking about bringing together structured and unstructured data, internal and external data. So big data might use my data warehouse as a source. It might pull data, structured data from my warehouse, combine it with my web logs or other unstructured data sets, and it might push data back into my data warehouse. So I need to be thinking about where am I going to put this? Am I going to put it in the cloud, in-house, or a combination of the 2? There's no right answer. There's no one-size-fits-all. Okay. I'm not going to read through all of these points. Acquire and deliver data anywhere. That was kind of what I just touched on in the last. This is when you don't read ahead, right? Acquire and you're going to get data from all over the place. Some of the data you want to use for big data analytics is external to your organization to start with. It makes absolutely no sense to bring a terabyte or petabyte or whatever these ridiculous huge numbers are. By the way, most big data implementations are 150 approximately gigabytes. They'll grow a bit, but that's kind of the ballpark. Data warehouse around 7 to 15 terabytes, sorry. So it's an order of magnitude bigger than your data warehouse. It's not the freaking numbers that people love to throw up there when they're talking about Amazon and Google and these big organizations that are actually just not real to the rest of us. But I want to be able to get that Amazon data. If I can get what my customer's doing when he's searching on Amazon, and I can link it into his credit card history, and I can do this, and then I can start to say, oh, how am I going to advertise that customer? What kind of customers do I want to target? So I'm bringing together data from multiple sources, and based on where the data is, do I want to deliver it into the cloud, or do I want to deliver it into my in-house environment? The governance, the security, and the metadata management is critical. If you don't know, the biggest challenge you have with a Hadoop type environment is you're throwing data in there, and if you let anybody do it, you start to replicate data. It's not easy to trace it. Your data lake becomes a data morass, a swamp is the term I've heard called. So you need the governance, and there's a variety of ways to do that. Most of them involve putting proprietary tools on top of your Hadoop type tools, which are have been more focused at the technology layer and less focused at the management layer, although that is starting to improve. Any delivery model, I'm just going to skip over the third point. Any delivery model. So what does that mean? Often we get tied into confusion about what big data is. So if you go back 2 or 3 years, every big data conference that one might have gone to, people were throwing up social analytics examples. Social analytics, by the way, is not big data per se. It's an example of using unstructured or semi-structured data, but it's not big data. What got very fashionable last year was a thing called Spark. Anybody heard of Spark? Okay. Or HANA. They're doing some good things with HANA, but real time is not necessarily big data. So big data is a combination of all of my standard traditional analytical models. It might be real time. Real time is typically where you say, I know what a condition is. When a particular condition is triggered, I want to do something. And that's when I need real time, normally. Historically, big data was batch. It was, I took my big file, I put it into Hadoop, I split Hadoop. So does everybody here or anybody here know what Hadoop is? Sorry. Have you heard of Hadoop? Okay, heard of it. So what Hadoop is, very simplistically, it's a database management system for unstructured data that is highly scalable and very high performance. And the way that it scales is it uses the speed of that the disk spins at to do analytics. So I take my big data set and I split it across 1,000 small disks, and I do 1,000 records on every disk. And instead of going and jumping around the disk every time I want to ask something, I'm going to do everything on that disk. I'm going to do everything on this disk. I'm going to run them in parallel, and it's going to give me a very high-speed batch analysis. All right, that's typically how MapReduce works. So I do batch very well, and then I'm also going to do streaming. So streaming is saying I want to be able to analyze single records as they come in. So security type examples might be that as an alert comes into my, or a particular condition is triggered in my event log that is suspicious. Where's security going? Security used to say, well, we'll buy an application that knows what known attacks are, and we'll look for those, and when we get one, we'll trigger an event, and somebody will look at it. Now the attacks are coming so quickly, and they're changing so quickly that we actually need to start saying, can we look at activity or behavior, and based on that, build a model that will start to predict that this looks suspicious and I need to investigate it further. So there's lots of applications for this kind of technology. And then, okay, well, that was just really the last thing, the last point. There are hundreds of applications. So we've got we're really partnering, I think in South Africa and even in England. I just had a phone call from one of the leading Hadoop distributors about 3 or 4 days ago, and we were having a chat about the partnering in this market. And he was talking about the UK and saying, well, even in the UK, they're 3 or 4 years behind where the US is. They're just starting to implement. In this country, my personal opinion is, and the big guys can shoot me down or disagree with me, is we are 4 years, 5 years behind where they are in the US, and that's historically typically where we are with any kind of technology. We are just really starting to experiment with Hadoop. And a lot of it is, give it to the IT department and let the data scientists come up with a problem. That was the initial thinking 2 or 3 years back. We have a problem with skills, we have a problem with a bunch of different factors that have all been covered, but the use cases are out there. So it doesn't have to be think big. It's look for those specific small problems that you have in your business. What's the questions that you cannot answer using your existing Microsoft BI suite? What are those questions that you need to answer and you can't currently do? There's an excellent chance that there's a big data application somewhere in there, but then go and do research. If you come to me or if you come to some of the other people here, they'll be able to say, guys, look at your industry. These are the kind of use cases where people in America or people overseas have got real value. There's an opportunity for you there, either in-house or in the cloud, depending on a variety of different factors. And that, I think, is me. Nope. So one last thing, just for the hell of it. Let me check. So this is the last slide. So I just pulled this from a Ventana research paper. They were talking about big data in the cloud and BI in the cloud. And what they did is they asked the question about cloud-based analytics, which for the moment I'm going to equate with big data. It's slightly different, but it's good enough. And this is what's becoming, I think, more and more of a factor, is usability in these kind of environments where I want to deploy quickly and get value quickly is becoming far more of a factor than almost everything else we're thinking about from I've got this report. If you want it, you can just get hold of me. Okay. Usability. The user is becoming the problem, or is becoming more and more the owner. And we've kind of gone this circle in IT, and we do this every few years, and I think I've been around probably as long as you have, Billy. where we start where IT has control. That was the mainframe. Then we invented client server. So when I first started working in the early 90s, client server was coming into play. And suddenly IT started to lose control. Then they started to get control back in IT on the client server environment. Then we invented mobile, and they started to lose control. Then they started to get back control. What data governance is saying is business needs to control this. It's actually not IT's problem. Business needs to tell IT what the rules are, and then IT can enforce them, rather than IT coming to business and say, you can't do BI in the cloud. It's not their decision. This is really just showing the same thing. We want to be able to give this to our marketing manager, to our business analysts, to our data analysts in a governed way. We still want to maintain the control that we need to maintain, but we need to give it to them in a governed way and let them do it. So, thank you.